So in this problem, we see the opposite scenario happening compared to what we just saw previously. Here we see a car loses about 10% of its value each year. And if it costs $15,000 now, how much will it be worth in 5 years, 10 years, and 2 years? So the same approach can be applied. We think, well, we're starting off with $15,000. And in that first year, what's happening is we're going to have to subtract 10% of that $15,000. That's in the first year. So, the same thing can be applied where we say, let's factor out that 15,000, and what we're left with is 1 minus 0.1, or in this case, now we have 0.9. So that means that if we wanted to find 5 years, we're basically doing the same thing. We take our $15,000. Actually, let's write that this is for the 5 years. We see that we're taking our $15,000 and we're basically multiplying it by this 0.9 a certain number of times. How many times? Well, it's 5 years. So it's going to be taken to the 5th power. So doing the calculations, that's about $8,857. Okay, if we wanted 2 years, or 10 years, then we have the 15,000 times 0.9 to the 10th power. And that gives us about $5,230. So for 2 years, that's just going to be 15,000 times 0.9 to the t power. All right. Next problem. In general, how do you get the multiplication factor? So what did we do in the last 2 problems? Basically, what we're doing is taking our starting value, our starting number, and we're multiplying it by, well, we always had 1 plus or minus, depending on the scenario, whether we increase or decrease something, the rate. But remember, it's in decimal format. Rate as a decimal. And then we take that to the t power. So let's break that down. We have our starting number. We have 1, which represents, in our problems, that was 100% of our original value. And that rate is either going to be increasing or decreasing our amount. And then keep in mind the rate is a decimal, and usually they give it to you in a percent format, so we change it to a decimal format. And then the t is representing our time. Okay. All right. Number 12, compare time to a straight line depreciation to number 11. So what that's basically saying is in number 11, that was not a straight line depreciation. It was an exponential decay problem, basically. In a straight line depreciation problem, what we're saying here is, let's take that 15,000 and let's take 10% of that, but it's going to be 10% every time. So what we're going to see is that we lose $1,500. It's a $1,500 decrease each year. And we know it's each year because as a straight line depreciation, we basically say here's $15,000 and it's losing the same amount each year. It has the same slope. It decreases 1,500 in 1 year, decreases 1,500 in 1 year, decreases 1,500 in 1 year. So that's a straight line depreciation. So our formula in that case would be, well, the amount given time is $15,000, what we start with, and we want to take off 1,500 each year, since 1,500 was 10% of 15,000. So if we were to do the same scenario where we want to find in 5 years how much that would be, we have 15,000 minus 1,500 times 5. That amount gives us $7,500. And in 10 years, 15,000 minus 1,500 times 10 would end up giving us $0. Okay, so straight line depreciation means basically your car will be worthless after 10 years. All right, the last problem here, number 13, just an extension of what we had done earlier. And this one, I said that we have to use our prior knowledge of negative exponents, of simplifying fractions, but now the other thing that we're going to see here, we're going to have to use some of our algebra skills. So as we take a look at this, we have 2 to the x power plus 8 over 2 to the x power equals 9. And the interesting thing about this is really, remember, we don't want that x on the bottom. We're solving for x now. So we can't solve for x if x is on the bottom. So how do we remedy that? Well, recall from Algebra 2, if we don't want something on the bottom, one way to get rid of that is by multiplying everything on the left side by its least common denominator and multiplying everything on the right side by its least common denominator. So multiply everything by 2 to the x basically. Well, 2 to the x times 2 to the x means how many 2 to the x's do you have? 2 of them. So 2 to the x squared plus 2 to the x times 8 over 2 to the x. Well, those 2 to the x's will cancel out and we're left with 8 equals 9 times 2 to the x. You can't combine them since they don't have common exponents, okay, or common bases even. So what we can do is just move everything over. We have 2 to the x quantities squared. What we're going to do is let's actually move that 9 over, that minus 9 times 2 to the x. So it looks like that. And then we have plus 8 equals, this goes away, so we have 0 on the right side. Now that looks pretty interesting. That looks pretty familiar actually. 2 to the x, that makes it look a little bit more complicated, but let's say that 2 to the x was really something else. Let's say y. So really this is the same thing as y squared minus 9y plus 8 equals 0. And that just becomes a quadratic. So we know to solve for that, we just need to factor that. Y squared minus 9y plus 8. That gives us y minus 1 and y minus 8 equals 0, which means y is equal to 1 and y is equal to 8. If y equals 1, we need to remember y is really the same thing as 2 to the x. So plug that back in. And what we have is 2 to the x equals 1. 2 to the x equals 8. Okay, 2 to some power gives us 8. 2 to the third. 2 to some power gives us 1. Well, anything to some power always gives us 1, and we should know that that's going to be a value of 0. So x equals 0 and x equals 3. Those are going to be your two solutions. And that's it for our notes.